Welcome to Risk Engineers Talk Governance. In this episode, due diligence engineers Richard Robinson and Gaye Francis discuss insurance criteria, its history, relevance today, and the highly protected risk process. We hope you enjoy their chat. If you do, please give us a rating and subscribe on your favourite podcast platform. If you'd like more information on R2A's work or have any feedback or topic ideas, please head to the website r2a.com.au.
Hi, Richard. Welcome to a podcast session today.
Hello, Gaye. It's good to be back again.
Back again, that's right. Today we're going to talk about one of the chapters in our larger book, the Engineering Due Diligence book, and we're going to talk about Chapter 5 criteria, and in particular 5.5, which is the insurance criteria, and the way that it was the history of it, which you're going to talk about in a moment, but also how it's relevant today. And we're particularly going to talk about the highly protected risk engineering process that's there. So over to you, Richard. Give us a blast on the history.
Right, Gaye. I wasn't too sure about that because, yes. Basically, I was just going to give a brief shot on what this HPR business is because I once upon a time trained with Factory Mutual a very long time ago in the US. And actually, I found it a bit more interesting than I was possibly anticipated because at that stage, being a fire engineer or anything like that was new and novel and nobody had a clue what it was. But from my point of view, basically derived from the Factory Mutual highly protected risk engineering approach. Now, the best way to actually explain it is just to explain how they started, because once you understand the history of them, you get the drift. They are actually quite different to Lloyd's of London, which took the wholly financial view of risk, whereas Factory Mutual took the engineering view of risk. And it basically started like this. In the 1840s, there was a bloke called Zachariah Allen, and he owned a cotton mill. And yes, you can smile at me, Gaye, and that's nice. Anyway, when you rip the cotton seeds out of the cotton balls, you get a lot of friction in a highly combustible medium, so these things used to burst into flame. And the cotton gins are wooden, the factories are wooden, so what tended to happen was cotton mills burnt down a lot. And this fellow called Zachariah Allen didn't like this, so what he decided to do was to build a better cotton mill. And the way he did that is that he fire isolated the cotton gins from the rest of the structure. He actually gave his people equipment with which to put out fires and taught them how to do it, like a fire hose. And with massive wooden construction, you don't actually get a fire that burns the place to the ground. If you put the fire out, you just get a slightly charred timber and it works fine. Having done all that, he then fronted up to his underwriter and said, look, what a good thing I've done, give me a discount. And the underwriter said, buzz off, the good pay for the bad, which is probably something you've heard in fairly recent times around the place. Mm. And so he said, if that's the way you feel about it, what I'm going to do is find other cotton mill owners or industrial owners who've re-engineered their facility to minimise losses, and then we're going to pay what we're paying you, our existing underwriter, into a mutual pool, and at the end of the insurance period, 3, 5 years, or whatever it is, we'll pay back to ourselves in profits what we didn't pay out on losses. Now, as a concept, this is pretty simple.
Yeah.
But it means you've got an engineered view of insurance, not a financial view of insurance. If you adopt the Lloyd's of London, and which I have to say most of the Western world continues to sort of flow through, a wholly financial view of insurance, it's just a matter of working out the odds. You can insure a burning building if you want to, as long as you've got the odds are right. Whereas with Factory Mutual said, no, if you haven't engineered it properly in the first place, we won't insure you.
The very, very early days of safety in design.
In effect, and that's the point. The Factory Mutual approach, it was always about control. It was never about levels of risk per se. That doesn't mean to say they didn't have reinsurance and all the other things that they do. Now, the other way they worked this out was because they did still have an insurance view in life, is that they then emphasised this business, the difference between, the way they defined it was normal loss expectancy, which is what the worst case loss should be if everything worked the way it's supposed to. In this day and age, that chiefly means automatic sprinkler protection.
Yeah.
And then they defined the worst case, which is the maximum foreseeable loss, which was typically determined by blank firewalls or separation. And that would be the worst loss that could occur on site. And so if you're a Factory Mutual engineer going to a site, you had to work out both these two things. And obviously looking at firewalls was the thing that could usually cause you the greatest grief. Now in Australia, this has caused an awful lot of problems because we don't quite understand this. And from a financial or design viewpoint, it's pretty straightforward. I mean, if you've got a building that's worth $100 and it burns down once a year, well, your annual loss expectancy is $100 per year. If you build a duplicate facility 100 metres away and it can burn down without touching the other one, well, that's $100 burning down once a year, and that's $100 burning down once a year. That's $200 loss expectancy. But if you put the two buildings beside each other and don't have them separated, each one will take the other one down when it burns down. You lose the lot twice a year, which means your loss expectancy is doubled.
$400 potentially.
Yeah. And you can see why underwriters and people like that really want to work out what the maximum credible foreseeable loss is, because that's what they really need to buy insurance and reinsure for. Now, as a design concept, this is pretty straightforward. But the trick is, and if you want to build your two facilities adjacent to each other, which from a cost point of view and land acquisition, all the rest of it becomes essential, you then have to put a firewall between them such that that firewall has the same effect as 100-metre separation. And this depends what you're trying to protect. And Australian standards and building codes don't really think this through very well for several reasons. First of all, they don't think about the load so much. They sort of go for a standard 4-hour firewall or something like that. Now, a standard 4-hour firewall is designed for a standard fire, whatever the hell that is. And there's a standard fire curve with a certain shape that you're meant to apply to a wall to see how it retains itself. Not so relevant anymore because we don't do it much, and we don't do much print anymore, but roll paper on end, and when they print big rolls of paper or make rolls of paper, they tend to just stack it up on top of each other on end. If one of those goes off, you can't put enough water on it to put it out. You cannot do it with sprinkler protection. You cannot do it with fire hoses. You have to wait till it burns out. But that means your firewall has to be a 48-hour firewall, which you can design and build.
But it's going to look very different to a 4-hour firewall.
The other thing where Australians get it wrong, because they tend to say that you can have a tied 4-hour firewall, which means you can have steel structures connected and a brick wall between it. Now, this doesn't work too well. You've got to design it so that when the side's burning down, as the steel collapses, it turns into ropes, and so it creates great tension. So you've got to design each side of the building to be able to resist that collapse forces on the building as it collapses, which is not an easy thing to do because you've got a dynamic fire and different loads and things like that. And the other thing which we get wrong is that the way we design our automatic sprinkler systems, we run the 6 and 8 inch water pipes through the top of the wall. Now I can tell you the one piece of steel that's going to have its full strength is the one that's got cold flowing water running through it. That's one of the reasons why steel sprinkler pipe works well for sprinkler protection, because once the sprinklers activate, that steel stays really cool and it retains its full strength. That means when your roof on one side collapses, it just brings the sprinkler piping down, and that rips the wall down. And the best part is that then takes out your sprinkler system on the other side of the wall.
So you're saying all your controls go, your firewall, your sprinklers and everything. So
correct.
That's why you
lose. Sometimes wonder why Factory Mutual gives their insurance reinsurance losses a pounding, and the reason is because Australian standards got it wrong and they didn't think it through. And then people keep designing to standards without actually thinking through functionally what it is that firewall is trying to do. And it's meant to withstand fire, burnout, and whatever's on the other side of it. So if it's pig iron underwater, which is a Factory Mutual line,
right,
you still have automatic sprinkler protection with Factory Mutual. Even if you've got pig iron underwater, you still have automatic sprinkler protection provided. But that means the firewall possibly doesn't need to be as robust as some other occupancies that you might conceive.
So it goes back to understanding what the issue of concern is.
Correct. Now, what's really strange about this is, Factory Mutual in Australia is based out of Melbourne. And that's the reason why the Risk Engineering Society, it started as a loss control section of the management branch of the Victoria Division of Engineers Australia, and it very nearly didn't join Engineers Australia. It was a very close vote. But that's the reason why it started in Victoria. What was interesting, one of my then business partners, Derek Viner, coined the term risk engineering because he took it off the Factory Mutual kind of approach to highly protect risk engineering. And that idea just flashed around the planet in a way that the rest of us were slightly astonished, which was quite impressive. But the other point I wanted to really make, which I think is sort of interesting from my point of view, because I hadn't thought of it like this. One of the Factory Mutual's arguments in life is that you can't take somebody who's learned about standards and then reteach them to become a highly protected risk engineer because they've acquired the bad habits.
Right.
No, this is very much like the Catholic Church. You've got to get them early, train them young, and then you'll keep them for life. Well, apparently you've got to take young graduate engineers, teach them the factory mutual approach, and they'll keep it going for life.
Right.
Which I suppose is my condition.
That's probably right, and then I've been trained by you, so... But
Well, that's one of the things, because I had this fascinating conversation. Again, the Americans are very, egalitarian, all this sort of stuff. You're at their research centre in Norwood, Massachusetts, and they're running the courses. You get dragged there, I think 3 times in the year that you're in America, and you get trained there. And I was having lunch with just sitting there, and one of the senior guys, one of the very senior guys, one of the vice presidents of Factory Mutual turned up, popped himself next to me and said, "Who are you? Why are you here?" And I said, "I'm an Australian and having a good time. Thank you for asking." Because Australians, I was trying to explain to these Americans that we got a holiday for a horse race in Melbourne. They would not believe me. They actually would not believe me.
yes.
Anyway, so I was talking to this fellow here, and I said, "Look, all the stuff that you guys are teaching is great, and it's really good stuff." But I said, you import people from all over the planet here. I was spending time with a Spaniard, and sharing a flat with a Spaniard, and then a Frenchman. And I said, and the retention rate of we young engineers isn't high. This is a huge investment you people are putting into it. The characters like us. I said, "Yeah, that's right." That's what he said. And I said, "Why do you do it?" He said, "Because you leave us and go and do good works in other places, and Factory Mutual prospers."
Right.
And I always thought, wow, the Americans always mystify me because they're so good in some places, and other places it just doesn't quite make sense. I told her that cartoon, they used to give me you flip over the desk calendar, and the agenda was sort of some Christian religious homily, and then you get to tax time and it says, next they're getting shot at and missed. Nothing's quite as satisfying as an income tax return. And I thought, only in America.
Yeah, and I don't want to compare those two.
I don't have a basis for comparison either. I do agree that tax returns are satisfying. But the point that what I was trying to say was that Factory Mutual was control focused. And that's how they started, and that's what they were trying to do. And they weren't relying on just the financial numbers, which the Lloyd's approach actually did.
I think that's one of the key takeaways from this, but also that you can't just design to standards.
Correct.
You actually have
to think through what it is you're trying to achieve. And if you fail to do that, nonsense arises. And how much nonsense have we seen from Australia's design to standards in recent times?
And the standards often don't apply or can't be applied to the actual situation that they find themselves.
Well, I don't want to bore people with fire standards and things like that, but in in the US, the Factory Mutual Sprinkler Standard is NFPA 13, which is the National Fire Code Sprinkler Standard, because it's an engineered standard. If they have a problem, something burnt down somewhere, they rack that material up, put it in the research lab and find out what sprinkler density actually is required. AS 2118, which is the Australian Sprinkler Standard, it might have changed a bit, but it started off from the Fire Officers Committee of the UK, i.e. the Insurance Committee, and it was a retrospective standard in the sense that if underwriters had a bad experience, they then increased the design density of the sprinklers.
But it wasn't tested or...
It wasn't an engineered standard. Yeah. It's just something that followed through. And that flows through to the way in which you design things. Remember how I said the firewalls and the sprinkler pipe takes it down when it for the fire... Well, again, it's got to do with scale, and there are reasons for this. America just industrialised that. If Australia compared to America there for a while, we just... we're less than one state.
We're little, yes.
We're little, right? We might be the 10th largest economy on the planet, but, San Francisco and California, I think, is the second largest economy out right now, isn't it?
Not sure.
Anyway, the point I make is that what they do is they put the water pipes around the outside of the plant, so that even if the walls collapse, you can't lose your fire protection water, and it's just a different design process. But that depends on the size of your factory. If you're only building a small one, I'd stick to Australian standards. If I'm building a big one, I'd definitely go with North American standards.
Yeah. I think standards might be a whole other podcast and a discussion that engineers have to have around standards.
Well, the funniest one that was though, and again, I was working at Factory Mutual at the time, they had a problem with a fire main. This was in Melbourne. They had a problem with a fire main, and they were digging holes to try and find it and couldn't find it. Right. And people were getting cranky and what's going on here? what had happened was the plant had been designed in Canada and had been then installed in Melbourne.
Yeah.
The pipe was had been installed to be below the permafrost level. That's why it was so far underground.
Which it didn't need to be the case
It didn't need to be the case in Melbourne. It would have been a lot simpler if it had been a little bit closer to the surface.
It does get cold, but not quite permafrost cold. So, a couple of takeaways. Look at what you're designing for. Have that understanding of maybe what's happened in the past doesn't necessarily represent what happens in the future, and be careful of standards. But I think we might cover standards in another podcast, Richard.
I'm sure that's going to be the case.
Well, thank you for joining us today, and thanks for listening, everyone. Bye.
Bye.